our previous video our previous video got cut when we were still doing our free body diagram at point C. So now we're going to continue with the free body diagram at point C. Okay. Then this one is going to be FCD. Again, our question said we should find the tension in cables AB, BC, and CD. So we were able to find our firstly we drew our free body diagram at point B. After drawing our free body diagram at point B, we then found our forces, the tension in cable AB and cable BC. So now we're going to find our tension at CD, and also we're going to find our theta angle theta. But before we do that, we have to draw the free body diagram for this system at the traffic light C. So yeah, let's carry on. And remember, we are still doing our analytical solutions. So yes, we're going to sum of horizontal forces that equate to 0. FBC always take left as negative and right as positive. So we're going to have negative FBC plus FCD. However, FCD we have to resolve it into component, which means we're going to have negative FBC plus FCD, the cosine of theta, which is equal to 0. We're going to substitute our value for FBC. FBC we found it to be 366 Newton. So negative 366 plus FCD cos theta is equal to 0. We are going to now solve for FCD. So we're going to take 366 to the other side, which is going to give us FCD equal FCD, the cos of theta, equal to 366 newtons. And that is going to be our equation. That is going to be our equation 2. Let us find the sum of vertical forces. For the sum of vertical forces, we have weight and force FCD, the y component of FCD. So yeah, let's go. Remember, upward always is positive and downward is what? Negative. Is equal to 0. Whereas Okay, let us resolve this into component. It's going to give us FCD, the sine of theta, minus our weight. They told us that our block weighs 15 kg, and we're going to multiply it by the gravitational constant, which is 9.81. So we're going to get FCD, the sine of theta, which is equal to 15 multiplied by 9.81. We are going to get 147.15 Newton. This is going to be our equation 3. This is going to be our equation 3. Okay, if we look at both equations, FCD cos theta is equal to 360 newtons, and FCD sin theta is equal to 147 newton. Both the equations I have two unknown, and both the equations, they don't have anything similar, which means we can't equate it or we can't subtract it. However, we could divide equation 3 by equation 2 in order for us to find the angle, which means when we divide equation 3 by equation 2, we will at the end, when we divide equation 3 by equation 2, the forces FCD and FCD, they are going to cancel out, and sine theta divided by cos theta is going to give us the tangent tan theta. Then we will be able to find our angle. So yeah, let's carry on. We are going to divide 3 by 2. Okay, what is our equation 3? Our equation 3 says FCD I am trying to find 2. Okay, it's fine. FCD, let us FCD, the sine of theta, which is equal to 147,15. We are going to divide this by equation 2, which means this is going to be divided 366,15, and this is going to be FCD cos of theta. FCD and FCD are going to give us 1 sin theta, and sin theta and cos theta, they're going to give us the tangent of theta, which is equal to 147,15 over 366,15. Therefore, for us to find the angle theta, you're going to do the tangent of 147, 15 all divided by 366, 15. Then we're going to punch this on our calculator. We're going to get our angle theta as 21.9 degrees. Since we have found our angle theta, we can substitute in either one of the equations, then we'll find FCD. So let us take equation 3. We'll substitute in equation 3, so that we can find So as I said, we'll take equation 3, which is FCD sine theta equal to 147.15 Newton. We'll substitute our angle. So let's do it. FCD, the sine of 21.9 is equal to 147.15. Therefore, we're going to get FCD is equal to 147.15 divided by the sine of 21.9. From there, we're going to punch it into calculator. Then we'll find FCD equal, which is equal to 379.02 Newton. Okay, now we're going to go to our graphical solutions. For our graphical solution, our scale is 1 centimeter is going to equal 100 Newton. So for our graphical solution, we are going to get okay, we're going to start with this one is at point B. At point B, we're given what weight? We're given weight. That is the first force that we are given. From the tail of our weight vector, we're going to draw a line that represents what? FBC. A line that represents FBC. Then from the head of our vector, we're going to draw a line that represent what? FAB at 15 degrees. After drawing this at FAB, then this one is FBC. After drawing this, you're going to measure them, which means you're going to find the weight at B is going to be equal to 98, 115 Newton, and the force at AB at BC is going to be equal to 366 Newton, and the force at AB is equal to 379,02 Newton. Remember that you have to measure them so that you can find accurate answers. So I can't measure this because I'm using my gadget, and I'm not using a ruler when I was drawing this, so my measurements will not be accurate, but yours should be accurate as I've explained step by step. So for the first polygon at point C, for this one is at point C. Okay, let's draw now. Okay, we were given our weight at C. This is our weight at C. From the tail, we draw a line representing what? FBC. You draw a horizontal line going to the left representing force BC. Then from the head you represent another line representing FCD at angle theta. From there you're going to use your protractor and your ruler to measure your measurement. At the end of the day, you have to find that your weight is equal to 147,15, and FCD. At the end of the day, you have to find that when you measure it, you have to find that it should be equal to 300 and FCD, it should be equal to 394.8 Newton. This is also measured in Newton. And FBC is obvious. I already found it above, so now you're going to just when you draw, you just measure it from the beginning because it's the first force that you got. It is equals to 366 Newton. From here, you will find that your angle theta, by using your projector. Remember, you have to use your protractor to find our angle, which is going to be equal to 21.9 degrees. So that's it. That's the end of our lesson. Thank you. I hope it was beneficial.